mutex. So the sync.readWrite mutex has a little more functionality. It has the same lock and unlock methods and works exactly the same way as a normal mutex, but additionally, it has two more methods, rlock and runlock. So the reason you would use a read-write mutex is because it allows you to have multiple readers at the same time. For example, it's actually safe to read from a map on multiple Go routines at the same time, as long as you're not reading and writing at the same time or writing and writing at the same time. Writing is the dangerous operation. So the way this works is if the mutex is locked, like with the .lock method, then no other Go routines can lock or rlock the mutex. However, if the mutex is just rlocked, then other mutexes can still rlock it. So you can get multiple readers, but you can't get readers and writers or writers and writers. It just allows many threads to concurrently read. So what this does is if you have a program with a shared resource where most of the threads are interested with reading the shared resource and you only have a few writers, you can make your code a lot faster by using a read-write mutex and allowing multiple readers at the same time. Your code will move faster and have fewer locks, slowing down and synchronizing your application. So on to the assignment. It says, let's update our same code from the last assignment, but this time we can speed it up by allowing readers to be read from the map concurrently. Update the val method to only lock the mutex for reading. Notice that if you run the code with a write lock, it will block forever. Okay, cool. So if I try to run it right now, it's going to have issues because I believe it is rlocked by the test suite out of the gate. So that's a problem. We can fix it by changing those to rlock and runlock. Perfect. Looks good to me. I'm going to go ahead and submit that. So a quick review on read-write mutexes. How many writers can access an RW mutex at once or at the same time? The answer is 1. And how many readers can access an RW mutex at once? It's going to be infinite. There is no limit. The next question is, can readers and writers use RW mutexes at the same time? The answer is still no, right? No one can use the mutex if it's being written to. Generics are an amazing new feature in the Go programming language. At least they're new as of the time of this recording. We're on version 1.20 now, and generics were just released in 1.18, and they were one of the most widely requested features by Go developers. So let's talk about what generics are and why they're so useful. Let's take a look at this code here. We have a function called split int slice. So it takes a slice of ints and it splits it into 2 smaller slices of integers. It effectively just splits the slice in half and returns 2 new slices. The really interesting thing about this function is that if you take a look at the function body, it doesn't actually care that this is a slice of ints. It could be a slice of strings or a slice of booleans. The logic in the function body would be the same, right? We'd calculate kind of the midpoint of the slice and return 2 new slices with all the values up to that midpoint. The annoying thing is that prior to generics in version 1.18, if we wanted to split a slice of strings, we would actually need to write an entirely separate function. Because in Go, we have static typing, and we need to tell the compiler what type of slice it is that we're splitting. Now, it is true that prior to generics, you could write a function that takes a slice of the empty interface, which is essentially a slice of anything, and then returns 2 slices of the empty interface. The problem with that is that you'd need to cast the return values back into whatever they were, which is kind of a dangerous runtime check. So generics, or type parameters, are really just a way for us to write that function with the empty interface, but do it in a compiler-safe way. Because if you think about it, the compiler can know that this function doesn't care about the types going in, but that anytime it's called, the types coming out will be the same as the types coming in. So how does it work? Well, we effectively have a new type of parameter that can be passed into a function. So after the function's name, we have these optional square brackets. And here we're defining a new type. We're calling it t, and we're saying it is of type any, or it can be anything. Now, because we are using t, the type parameter, as both the input and the output, we're telling the Go compiler, hey, whatever I pass into this function, that's what I'm expecting to get back out, right? If I pass in a slice of integers, I expect to get out 2 slices of integers. So now if we take a look at how the code is actually used, right, how the function is called, we can use the split any slice function, give it a slice of integers, and we'll get back 2 slices of integers. Everything is type safe. So in a nutshell, the reason to use generics is to dry up our code, right? Dry is just an acronym for don't repeat yourself. It's a way of writing code that can be reused more easily. So instead of having to write 2 nearly identical functions just to deal with 2 separate types of slices, we can now write a type safe function once and reuse it throughout our application. So let's jump right in. The assignment says, at Mailio, we often store all of the emails of a given email campaign in memory as a slice. We store payments for a single user in the same way. So those are 2 very different things, right? Emails and payments. Complete the getLast function. It should be a generic function that returns the last element from a slice, no matter the type stored in the slice. If the slice is empty, it should return the 0 value of the type. Okay, cool. Let's get started. Okay, so we can kind of use this syntax as a guide. So we're going to need to specify a type. It can be anything, like the assignment said. And we're going to take as input a slice of that type and return 1 element of that type. Okay. Now it says we need to return the last element from a slice. So we need to slice the slice, essentially check its length, right? So we can say if the length of s is 0. So if there's nothing in the slice, we're going to have to just return the empty type of t, which down here it says we can create a new empty variable like this. So we'll just do var 0 val, and then we'll just return it. Okay, cool. So if the slice is empty, we'll return the 0 value. Otherwise, we'll return s at the length of s minus 1, right? Okay, so if there's nothing in the slice, we'll return the 0 value. Otherwise, we'll return the element in the last index. And the reason we have to do this guard clause is because otherwise this would be an unsafe operation. We'd get an index out of bounds error if we tried to do this operation on a slice of 0 length. So let's go ahead and run it. And it looks like... Okay, so the test case with a 0 length slice returns an empty struct. That looks correct to me. Getting last email from a slice of length 3. There's the last one. Looks like it returned it correctly. And then here we have payments, right? So a completely different type. And the last one is jane@example.com. Yep, that looks correct to me. Margot. Cool, let's submit it. So why are there generics in the Go programming language? Well, there's kind of 3 main points that are important to understand. The first, as we already covered, is that generics reduce repetitive code. So whenever we have code that doesn't really care about the type, or maybe it only cares about a small superficial part of the type, then we can write more abstract and more reusable code if we have access to generics, right? Because it keeps the code compile time safe and type safe. Before in Go, if we wanted to reuse code, we had to do sort of dangerous runtime checking, right? Casting things to empty interfaces and back from empty interfaces. It's also important to understand that generics are going to be used much more frequently in libraries and packages. If you're, say, a backend developer and you're building applications and not libraries or packages that are intended to be used by other people, you probably don't need to use generics all that often, which is why the Go programming language was able to get away with not even supporting them for so long. Now, if you do work on libraries or packages, or maybe you're even a contributor to the Go standard library, then you probably are going to use generics quite a bit more. They'll make it a lot easier to write more abstract code that's useful for more and more use cases. The last point that's important to understand is just why did it take so long to get generics into the language, right? They're super useful. Why didn't we add them, 5 years ago or a decade ago when Go was kind of getting started? The answer is that one of the philosophies behind the Go programming language is just to kind of keep it simple. Go doesn't have all that many features because Go developers and Go maintainers don't buy into the idea that more features necessarily makes a better programming language. By having fewer features, it means there's less to learn to get up and running with the language. It also means that anytime you see a piece of Go code, you'll have an easier time understanding it and working with it. So even more so than other languages, the Go team is very hesitant to add new stuff. So generics were in the works for a long time, and it was only after many years of thinking about it and making sure that we really needed them that they actually got their way into the language. So the question here is, what code would generics be most likely to help with? A binary tree, detecting whether or not a string contains a given substring, or calculating the area of a circle? Well, detecting whether or not a string contains a substring will probably just use string types, and calculating the area of a circle just sounds like floats to me. But a binary tree is a data structure that can store any type. It's kind of like, a slice in that way. So I'm going to go with binary tree on that one. The next question is, Go's approach to language design is to support as many useful features as possible, to resist adding new features until they're extremely important or proven extremely important, or to never add new features. The language doesn't change. And the answer is to just resist adding new features unless they're proven to be very, very important. The next question is, generics will probably be used more heavily in blank. Main packages, which are executable applications, or library packages. And I definitely argue that they'll be more heavily used in library packages. Okay, so we've talked about how generics are super useful when the type that is being used in your function doesn't matter, right? When it can be anything. But constraints allow us to write generics that are actually just useful for a subset of types, right? So maybe this function doesn't care too much about the types that are being used, but it does care a little bit. So let's take a look at an example. This concat function is similar to the other generics that we've worked with. The big difference is that the type t, the type parameter, instead of being able to be anything, we're saying it has to be a stringer. Right? And we've specified the stringer interface here. It's just anything with a string method on it that returns a string. With the built-in any constraint, which is effectively the empty interface, we can't really do anything with the values inside the functions, right? Which is why it works for something where we're just, say, splitting a slice of that type. But in this function, the concat function, we're actually able to use the type a little bit. We're able to call the method that's implemented on it. And that's just because the only thing that we know about these values coming into the function is that they have that string method. So what does the concat function do? Well, it takes a slice of stringers, it loops over all of them, grabs the string representation, right, by calling that string method, the string representation of each value, and then kind of just mashes them all together, right? It concatenates them and returns the result. So let's take a look at the assignment. We have different kinds of line items that we can charge our customers credit cards for. Line items can be things like subscriptions or one-time payments. Great. Complete the charge for line item function. First, it should check if the user has a balance with enough funds to be able to pay for the cost of a new item. Okay, so we're given a new item, which is of type T, given a slice of old items, and a balance, which is just a float. If they don't have enough funds, then we'll return an insufficient funds error. But if they do have enough funds, then we'll add the line item to the user's history by appending new item to the slice of old items. Okay. This new slice is your first return value, right? So we're returning 3 values here. So we're returning kind of the new list of old items after a new item has been appended. And we need to calculate the user's new balance by subtracting the cost of the new item from their balance. This is my second return value. Okay, cool. So we take in their balance, we're going to subtract the cost of the new item, and then return the new balance. And obviously, if nothing went wrong, we'll return a nil error. Okay, so we have the type here as a line item. So line item is this interface, and it looks like we kind of have these 2 methods available to us within our function. We can get the cost of a line item, or we can get the name of a line item. So the first thing our function is supposed to do is check if the user has a balance with enough funds. So we need to do something like new balance is equal to balance minus the new item dot get cost. right? So we're going to check what the new balance would be after subtracting the cost of the item from the user's balance. Then we can say if the new balance is less than 0, then we'll return this insufficient funds error, right? And 0 values for everything else. So it'll be nil slice, 0.0 float, and errors.new, insufficient funds. We'll need the errors package. Okay, cool. Otherwise, that means this this balance is 0 or greater, right? And it says add the line item to the user's history by appending it to the sliceable items. So we could do old items equals append old items new item. Okay. This new slice is your first return value. Great. Otherwise, and then calculate the user's new balance by subtracting the cost of the new item from their balance. So we already did that. This is your second return value. So I think we could just return old items, new balance, and nil, right? Let's go ahead and run that. Okay, charging customer for a yearly subscription, current balance is 1,000. New balance is 750. Total number of line items is now 1. So for monthly subscription, new balance is less. Total number of line items is now 3. Let's go take a look at those test cases just to make sure that this makes sense. Okay, so they had 0. Now they have 1 subscription. Here they had 2 subscriptions. Now they have 3 subscriptions. Cool. That looks, or 3 line items. That looks good to me. I'm going to go ahead and submit it. When generics were released, a new syntax for writing interfaces was also released. Partly just because this new syntax is super useful if you're trying to use interfaces as constraints for your generic functions. So let's take a look at an example. A type list is pretty much as simple as it sounds. We're basically just creating a new interface. In this case, we're calling it ordered. And then we're just listing all of the types that we're saying implement that interface. So there's no methods here, but the interesting thing about all of these types is that they all support these inequality operators like less than or equal to, greater than. And so if we use ordered as a constraint, then we're free to use these comparison operators on that type. And the question that goes along with this is, why might you create an interface using a type list? And the answers are, you know exactly which types satisfy your interface, or it's too much trouble to define the methods required by your interface. That second one is a bad reason. You would really only do this if you know exactly which types satisfy your interface. Let's take a look at parametric constraints, which sounds like a kind of complex term, but it's actually really simple. It basically just means that we can use type parameters in interface definitions as well. So instead of just creating interfaces, which we then use in our type parameters for functions, we're actually using type parameters to define new interfaces. So for example, here we have a store that takes as a type parameter P, which is a product. Now a product is just an interface, right? A product is anything that can return a price and a name. So a store, which is, again, an interface, is just anything that can sell a product. Now, the idea really is that simple. If you want to get an idea for kind of how this whole snippet of code works, the example code, I'm not going to talk through every line. That would take a little bit too long, but feel free to kind of browse through this and get a feel for how that interface works. We're going to jump straight into the assignment. So getting on to the assignment. Says the chief architect at Mailio has decided she wants us to implement billing with generics. Specifically, she wants us to create a new biller interface. A biller is an interface that can be used to charge a customer, and it can also report its name. Okay, so let's take a look at what a customer is. So a customer is this interface. It's just anything that has a get billing email method on it. So in this case, a user is a customer and an org is a customer. Okay. And it can also report its name. Okay, that's simple enough. There are 2 kinds of billers, user billers and org billers. Okay, so we've got user biller here and org biller here. Create the new biller interface, which have 2 methods. Okay, so let's go ahead and do that. Type biller interface. Two methods, charge and name. The good news is the architect already wrote the user builder and org builder types for us that fulfill this new builder interface, right? We took a look at that. Use the definitions of the types and their methods to figure out how to write the builder interface on line 7. Okay, cool. So let's start with name. It looks simpler. So a user builder has a name method. It takes no parameters and returns a string. Same with the org builder. So that one's simple. It just returns a string. Okay, the charge method for a user builder accepts a user, returns a bill. But for the org builder, accepts an org and returns a bill. Okay, so it always returns a bill. That part's easy. But what it accepts is a little bit different, right? And if we take a look at the customer interface, where did it go? Customer interface here. Then we see that we have this common interface that we can use to represent both a user and an org. Okay, so that's convenient because we can use that interface, right, as a parametric constraint. So let's create a new parametric type, or we'll create a new type parameter. Call it C because it's a customer. Should be easy enough. And then charge will actually take as input C. Right? It will take a customer rather than specifically a user or an org. Okay, let's try that. It compiled at least. Let's see what we got. Using basic user builder to create a bill for Joe at example.com, $50. Basic user builder for Samuel Boggs, $50. Pro user builder for Jade, $100. Okay, that's looking correct to me. It looks like the pro and basic have a discrepancy of $50 and $100, and then the org biller is being used here, and you can see it's actually much more expensive. So that looks correct to me. So let's talk about naming generic types. We can take a look at this old example, or the example from earlier in the course, where we had this split any slice, right? And it has t as a type parameter of type any, and then we use t kind of all throughout the function signature. T is just a variable name. We don't have to use t there. We could name this whatever we want, right? We could name it my type, whatever the heck we want, right? Slice value. It doesn't matter. However, it turns out that capital T is actually fairly common convention when there is just a single type parameter for a function. So the question here is, the name of a type parameter blank can and should be whatever you want, can be anything, but T is a common convention, or must be T. It turns out it can be anything, but T is a fairly common conventional name. Rob Pike, one of the creators of the Go programming language, created an awesome set of proverbs that outlines some more of the philosophies behind the language. I'm not going to read them all to you, but I am going to cover some of the ones that I think are the most important. And if you are interested, I'd highly recommend going and watching his talk about the proverbs if you want to go more in depth on them. So let's start at the top. Don't communicate by sharing memory. Share memory by communicating. So this basically is telling us we should probably try to use channels more often than we use mutexes when we're trying to share memory between Go routines. Which leads right into the third one, which is channels orchestrate and mutexes serialize. So when we use channels, we get kind of this elegant flow of data through our program, right? One Go routine did something, another Go routine can react to it. Mutexes are all about just locking access to protected resources. If we can use channels to express logic in our program, it will tend to work a little bit better. Another great one is that the empty interface says nothing, right? Every type in Go fulfills the empty interface. You should really avoid using the empty interface just because it doesn't tell you anything interesting about your types. The empty interface is sometimes used by new Go developers to kind of get around the type system, and that just leads to unsafe code. Go format style is no one's favorite, and yet Go format style is everyone's favorite. So we'll get into this in just a bit when we jump into the project, but the Go toolchain comes with its own formatter. And pretty much every production piece of Go code out there uses the same formatter, which is fantastic because it means all Go code looks the same. While not everyone necessarily agrees on the formatter's choice of, say, tabs versus spaces, it's still everyone's favorite because it means we all get something consistent that works reasonably well. The next one is one of my favorites. It's a little copying is better than a little dependency. Now, if you've ever worked in the JavaScript ecosystem with node modules, you'll know exactly what this means. Node modules is typically a huge folder, and a lot of times when you're working on a front-end framework, your dependencies are much greater than your actual application code. And in Go, we typically just kind of invert that way of thinking. We want our application code to be the bulk of the code within our project, and we tend to use far fewer dependencies as almost a philosophy. And this brings us to the one mentioned here in the question, which says, which is better, clear or clever? And at least according to Rog Pike, clear is better than clever. So if you can write your code in a way that is very clear to anyone else reading it, or even just to yourself, that's better than trying to do a trick that might seem clever, but is actually hard for humans to understand. Remember, code is written for humans, not for machines. The next question is, which is better, copying a little code or including a small dependency? And Rob Pike would argue that it's typically better to copy a little bit of code rather than include a very small dependency in your project. The next one I want to point out is that errors are just values, right? In Go, error is just a specific interface, and we return it from functions just like we do any other value. There's not some special way to handle errors with tries and catches. Errors are just values, and we deal with them just like we would any other value. And the last one I want to point out is that documentation is for users. And this is actually an interesting one. I think what he's saying here, and I need to go rewatch the talk to confirm, but that documentation is primarily for people who aren't maintaining the code. In other words, it's best if the code itself is really easy to understand so that it doesn't need to be heavily documented so that other maintainers can work on it, right? Documentation, in the sense that, we should be writing external documents that explain how the code work or how to use it, should be for the users of our code, right? In the sense that if we're writing a library, we should be writing documentation for the users of the library, the developers calling our exported functions, right? Not the maintainers of the library itself. So documentation should primarily be written for the users of your code. It's time to build a fully fledged backend server in Go from scratch on our local machines. The purpose of the server will be to aggregate data from RSS feeds. If you're not familiar with RSS, it's a protocol that makes distributing things like podcasts and blog posts really easy. So what our server will allow users to do is add different RSS feeds to its database, and then it will go automatically collect all of the posts from those feeds and download them and save them in the database so that we can then view them later. Before we get started, there are 4 things you're going to need. The first is a basic understanding of SQL, the language that's most often used to query relational databases. If you're not familiar with SQL yet, that's okay. I've got a full course on SQL. I'll link that down in the description below. Go watch that, then come back here if you're not familiar with SQL. Number 2 is you're going to need a text editor and a command line. I'm using VS Code and ZSH here in the video, so you'll see me using that. Feel free to go download those if you want to try them out, but you can use whatever text editor you want as long as it can edit your files and you have access to a terminal to run commands. Number 3 is the Go programming language itself. If you don't have that, you can go download it. I will link the download page down in the description below. And I'd also recommend just installing the Go plugin. If you're in VS Code, there is an official Go plugin. Go download that. It'll make your life easier with syntax highlighting and formatting and that sort of thing. Number 4, the last thing you'll need is an HTTP client. So an HTTP client will allow you to make, get, and post and put requests into the web server that we're building. We'll need that for testing. I use the Thunder client. It's a VS Code extension, but you can use anything you like, even curl on the command line or Postman, Insomnia. There's tons of choices. Google HTTP clients, or if you don't already have a preference, again, if you're in VS Code, I'd recommend the Thunder client extension. Now that you have all of those tools installed and hopefully working, let's jump into the project. The first thing we're going to need is just a main.go file. We'll create our entry point. It will be a part of the main package, and it will need a main function. So func main takes no arguments, returns no parameters, and for now, let's just print hello world, make sure we can kind of build and run this program. We're going to need to initialize a new module for our project. So I'm going to do go mod init. And I like to name my modules after their remote path, right? Where they will exist kind of out on the internet. So in my case, I use github.com / my GitHub namespace, which is Wags Lane, / the name of this repository, which again is where I'll be keeping this code on GitHub. So I highly recommend you keep track of this code in GitHub. This entire project should be checked into Git and uploaded to GitHub or GitLab or whatever you prefer. So I'm going to name this repository RSS aggregator, RSS ag. So we'll go ahead and create that. That will create this new Go module. And now that that's ready, we should be able to just go build and execute the new binary or the new executable that will be created from go build. In fact, I'll just run it once so you can see. That created this new binary file here in my current directory. And so from now on, I'll be running this command, go build and /RSS ag. So that will build and run. And we got hello world back, so we're good to go. Like I said before, we're going to be building this project with Git and storing our code in source control as we go. So I'm going to go ahead and create a new Git repository. And in VS Code, it highlights all the code that has changed but not yet been committed to source control here in green. But I don't want all of this in my source control. The .vs code file is configurations for my editor. That's a personal thing that doesn't need to be in the project itself. Same with the RSS ag binary. We don't want to commit the binary that we're building or the executable file that we're building. We just want to commit our source code. So I'm going to create a new .gitignore file. And we're going to ignore the .vs code folder and the RSS ag binary. And next, we're going to add all of the secrets, the configuration secrets for our project in a .env file and read them out of the file itself. So for example, one of the configuration variables that we're going to set is the port that the server will run on. So I'm going to set that port to 8000. And I'm going to also ignore that .env file in the gitignore. Again, because configuration data is something kind of local to my machine, in production, this port might be something different. So we don't need to commit this file to source control, but I do want it here in my repo. Now, at this point, I do want to pause and say, if you have no idea what a port is, or you have no idea what HTTP requests are or REST APIs are, we're going to move fairly quickly in this project. So if you're not familiar with that stuff, again, I will link down in the description below my HTTP course. That would be a good one to go brush up on before working on this project. So now we need a way to read this port variable into our program so that we can use it. And the Go standard library has a built-in function called os.getEnv. So it's an exported function called getEnv from the OS package. And we can get the value of a variable by its key. So in this case, the key is port. And we'll get back a port string. And then for now, let's just say if port string equals the empty string, then we'll say log.fatal. So log.fatal will exit the program immediately with error code 1 and a message. And we'll say port is not found in the environment. Otherwise, we'll say port, and we'll print the port string. Okay, cool. Let's go ahead and run that. Port is not found in the environment. Okay, so the problem here is that port, the environment variable, doesn't exist in my current shell session. If I wanted to add it, I could run in my command line export port equals 8,000, and then run this again. And then we get port equals 8,000. The problem is I don't want to manually set this environment variable every time I work on my server. I want to pull it from this file. So we're going to use a package that allows us to grab environment variables from a .env file. And it is this package here, github.com/joho/go.env. That's also the URL of the library. You can paste that into your browser, go check it out. But we're just going to install it here locally. And that will add it here to our go.mod. And then I'm going to run go mod vendor to copy that code here into my vendor folder. We get kind of a local copy of that. We'll run, here we're going to need to actually use it. So we do go.env.load. And by default, loads the .env file. I think we can also optionally pass in .env as the file path. And what's my error here? Could not import. No required module provides. Let's go mod tidy. That should clean up my imports. Okay, perfect. And do I need to do anything else? What are we getting here? Could not import. No required module. Oh, I should probably go mod vendor again. That should pull in the code. Okay, so you can see we've kind of imported and downloaded all of that code from the package. And now I'm not getting any errors in my console. Okay, so this will take the environment variables from my .env file and pull them into my current environment so that then I can use os.getenv to load the variable. So to test that, let's go ahead and change the port to 8080 and rerun the server. Still says 8,000, so something went wrong. Maybe I'm misremembering how to use this package. Let's try just go.env.load. Still port 80. What am I doing wrong? Does it not overwrite? You know what? It might not overwrite my current session. I'm going to kill my current shell session and create a new one. And then we'll do this again. So now I won't have that exported 8,000 that I had in my terminal. Run that again. Okay, cool. So now it's pulling it from the file because I don't already have it defined in my shell session. Now, I want to take just a second and point out there are text instructions for this entire project over on boot.dev, and I'll link that down in the description below. We're going to be using a lot of text, code snippets from those text instructions, and they'll be easier to kind of copy and paste and grab from boot.dev directly than trying to, retype what you're seeing me type here on the screen. Now we're going to actually spin up our server, and we're going to be using the Qi router to do it. It's a third-party router, very lightweight, built on top of kind of the same way that the standard library in Go does HTTP routers. And so let's go ahead and install those now. We'll do go get github.com/go-chi/chai or Qi. I always struggle to pronounce that one. We'll install that, and we'll install the cores package from the same namespace, the Qi namespace. Next, we'll create a new router. So I'll do router : Qi.new router. In fact, I should probably go mod vendor. Have it there, and then I'll do another go mod tidy and go mod vendor to bring it in. Cool. So this creates a new router object. Next, we'll connect up this router to an http.server. So at serve : pointer to an http.server. And a server needs a handler, which will be the router itself. And we also need an address, which is just a colon plus that port string. So in this case, it'll be colon, 8080. Cool, and then we can call http.listen and serve. Or sorry, not http.listen and serve. We want to call it on the server object. So serve.listen and serve. Cool. And before we call that, in fact, I think that returns an error. So let's capture that error and say if error does not equal nil, log.fatal. Pass in the error as a message. Okay, listen and serve will block. So when we get to line 30, our code basically just stops right here and starts handling HTTP requests. If anything goes wrong in the process of handling those requests, then an error will be returned and we'll, log it and exit the program. But kind of the happy path for our code is that, nothing should ever be returned from listen and serve because our server is just going to run forever. Before we run this, let's just add one more kind of logging statement. We'll do log.println. Actually, let's do printf. And we'll say server starting on port %v, and we'll pass in that port string. Okay, cool. With that, let's go ahead and build and run again. So go build. See what we get. Hello world, server starting on port 8080. I should probably remove that hello world at this point. Now that we have a running server, let's go ahead and test it. So I'm over here in the Thunder Client tab, again, because I'm using the Thunder Client plugin, and I'm going to click New Request. And we're going to make a request to http://localhost, right? We want to make a request to our own machine on the port that we're running on, which I believe is 8080. Okay, with that, let's go ahead and start up our server. Okay, server starting on port 8080, so it should be good now. You'll see I don't have a new prompt because my server is still running. If I send this GET request, perfect, we get a 404. That's exactly what we'd expect because remember, in our code, we haven't actually set up any handlers or anything. We just have a server running. So we're getting a 404 because we're trying to hit a path, in this case, the root path, and it doesn't have any logic there to handle that code. If we killed our server and ran it again, we'd just get a connection refused. I've configured my Thunder client to actually store all of my tests or my HTTP requests as plain text here in the working directory, but I don't want those going into my source control. So I'm going to go ahead and add that to the git ignore. Thunder-tests will ignore everything in there. Next, let's add a CORS configuration to our router. So this is so that people can make requests to our server from a browser. And we're going to be using some fairly permissive configurations here. And we'll use router.use, and then we'll pass in this CORS.handler configuration. This comes from that CORS package that we installed earlier. And let me see, what am I doing here? We need one more parenthesis there. And then I'm going to go ahead and vendor this as well. So go mod tidy, go mod vendor. Cool. So we should have all of that code here in our vendor folder as well. I'm not going to go too in depth on exactly what cores are. You can definitely go look that up. But just to give you a high level overview, this configuration is essentially telling our server to send a bunch of extra HTTP headers in our responses that will tell browsers, hey, we allow you to send, requests to HTTP or HTTPS versions. We allow you to use these methods. We allow you to send any headers. It's just a way to say, hey, we're going to allow you to do basically whatever you want. There are ways you can tighten up this configuration for security purposes, but for now, we're just going to be running our project on our local machine. So we're going to just open it up, make it permissive to avoid any sort of kind of weird testing issues if we try to connect to our server through a browser. This server we're building is going to be a JSON REST API, which means all of the request bodies coming in and response bodies going back will have a JSON format. So let's create a little helper function that will make it easier to send JSON responses. So I'm going to create a new file, call it json.go. It's going to be in the main package. And the function signature is going to look like this. So we've got a function, we're calling it respond with JSON. It takes as input a response writer. This is the same HTTP response writer that HTTP handlers in Go use. It's exposed by the standard library. It will take a code, so this is the status code we're going to respond with, and then it will take an interface, which is just something that we can marshal to a JSON structure. The first thing the function will do is marshal the payload into a JSON object or a JSON string. And the way we do that is with the standard library. So we data and error equals json.marshal, and we pass in the payload. So this function will attempt to marshal whatever it's given into a JSON string, and it will return it as bytes. And the reason it returns it as bytes is so that we can write it in a binary format directly to the HTTP response, which is pretty convenient. If that fails for whatever reason, then what we'll do is we'll write a header to the response, and we'll use status code 500. We'll say something went wrong on our end, right? Internal service error or internal server error. And then we'll just return from the function. And actually, if something goes wrong, we should probably log it as well on the server side so that we can see our own logs and see, hey, we tried to do something and it broke. So we'll do log.println failed to marshal JSON response. And let's print the response. Or let's print what we tried to marshal. That's probably more interesting. We'll use printf so that we can interpolate that value there. Next, we're going to need to add a header to the response to say that we're responding with JSON data. So we'll do w.writeHeader. Or not write header, I'm sorry. W.headers. Is it header? Add, and we want to add to the content type key. So content type, and the key will be the value will be application JSON. So this adds a response header to the HTTP request saying, hey, we're responding with a content type of application/JSON, which is the standard kind of value for JSON responses. And then we should be able to write the status code. So we do w.writeHeader 200, so everything went well, and then we need to write the data itself. So w.write and pass in the JSON data. This will write the response body. Now that we have a way to respond with some JSON data, let's create an HTTP handler that does that. So we'll do handlers or handler readiness. Again, this will be in the main package. And we're going to create a new function called handler readiness. And this is a very specific function signature. This is the function signature that you have to use if you want to define an HTTP handler in the way that the Go standard library expects. So it always takes a response writer as the first parameter and a pointer to an HTTP request as the second parameter. And then in the body of this handler, we can just call our respond with JSON function. So we'll say respond with JSON. We'll pass in that HTTP response writer. We want to respond with a 200 status code and some response payload. In this case, all we care about is the 200 OK status code. So I'm actually just going to respond with an empty struct, which should marshal to kind of an empty JSON object. And now that I'm writing this, I realize that we actually made a mistake, or I made a mistake in the JSON respond with JSON code. We should pass in, we should use the passed in response code instead of hard coding the 200. So if everything goes right, we'll use the code given. Okay, now with that, we need to hook up our handler. Now, using the chi router, what we do is we hook up an HTTP handler, which is this function, to a specific HTTP method and path. Okay, so the way we're going to do that is I'm going to create a new router. So v1 router. And we'll use that same chi.newRouter to do it. And I'm going to specify v1 router dot handle func, excuse me. I want to handle the /ready path, and I want to handle it with this handler readiness function. Okay, so we're connecting the handler readiness function to the /ready path. And the reason I created this new v1 router is because I'm going to mount that. So I can do router.mount to the /v1 path. Okay, so I'm nesting a v1 router under the /v1 path, and I'm hooking up the readiness handler at the /ready path. So the full path for this request will be /v1/ready. And that's just so that if we make breaking changes in the future, we can kind of have two different handlers, one under version 1 and one under version 2 for our REST API. This is fairly standard practice. And actually, I'm going to name this path health Z. That's just a habit that I'm bringing with me from Kubernetes land. That's pretty standard to have a /health_z path that you can hit to see if your server is live and running. So that's the purpose of this handler. It should just respond if the server is alive and running and everything's good. Okay, so let's go ahead and run the server and make sure it's doing what we'd expect. So go build and /RSSAG, that starts up the server. And then we can open up Thunder Client. And now, instead of making a request to the root, which we'd expect to get a 404 from, we'll do /v1/healthz and make that get request, and we get the 200. Now, here's the weird thing. If I change this to a post request and I make that, I actually still get a 200, but that's not really our intention. The health_z endpoint should really only be accessible by GET request. So I'm going to make an update here. Rather than using the v1router.handle func, I'm going to use v1router.get. And this will scope the handler to only fire on GET requests. Okay, with that, let's go ahead and rebuild our server and check again. Post should fail, method not allowed, perfect, but the GET request should still work. So we have a nice helper function for responding with arbitrary JSON. Now I want one for responding with arbitrary error messages. So let's do function respond with error. It will look very similar, but instead of taking a payload, which is an interface, it will take a message string. And this function is basically just going to format that message into a consistent JSON object every single time. Okay. First thing we're going to do is say if the code is greater than 499, we're going to log a message. And that's because error codes in the 400 range are client-side errors, so we don't really need to know about them. It just means someone's using our API in a weird way. But we do need to know whenever we're responding with a 500 level error code, because that means we have a bug on our end and we should probably go fix it. So we'll do log.println. Responding with 500 level error, and we'll just tack the message itself on there. Okay, cool. After we do that logging, we'll use the respond with JSON function, but we'll be responding with a specific structure of JSON. So let's go ahead and define that as a struct. So type error response is a struct, and it has one field, error, so just a string. And we'll add this JSON tag to just say the key that this should marshal to is error. So in Go, we typically take a struct and add these JSON reflect tags to it to specify how we want this JSON.marshal function, or on the other side, the JSON.unmarshal function, to kind of convert this struct into a JSON object. So in this case, we're saying, I have an error field, it's a string, and I want the key for the field to be error. So this struct will marshal into a JSON object that looks kind of like this. Error, something went wrong. Right? It wouldn't have, actually wouldn't have that, but it would look like that. Okay? And we'll see that in just a second. Okay, so now we get to respond with JSON. We pass in the response writer, the same code that we were given, and then we'll just respond with an error response, and the error message will be the message that we were given. Okay, let's hook this up to another handler. So here we can do v1router.get. We'll create an error endpoint, and I need an actual handler. So we'll create a new one called handler error. Handler error. And we'll respond with an error. Instead of passing in an empty struct, we'll say something went wrong. And we'll respond with a 400 status code. Client error, right? Okay, now we can hook up this error handler here. It will only work on GET requests. That seems reasonable. And basically, it's just going to call that respond with error function. So it'll be a good way to test that. Okay, let's go ahead and rebuild the server. Oh, what did we screw up? Routing pattern must begin with /. Let's go fix that. So you can see here we've got /healthz /v1. We need to start these with a slash. It's just the way the chi router works. Cool. Let's go open up the Thunder client and send a request to the /error handler. Cool. We get the 400 bad request status code, and this is that JSON body. So every single time that we need to return an error from our server, now we can just use this function and it will always use this consistent error format, which is great because we can throw this in our documentation and just tell all of the users of our API, hey, this is what you should expect when something goes wrong. Now that we have a little bit of our boilerplate set up, I'm going to take the opportunity to commit all of this to Git so that I don't lose it. I will say that I generally recommend committing the vendor folder. So you can think of the vendor folder kind of like the node modules folder if you're familiar with JavaScript land. And in JavaScript, you would never commit it. It's way too big. But in Go, we typically don't have all that many dependencies. So it's actually perfectly fine to commit the vendor folder in most scenarios. And I'd even recommend it. So I'm going to go ahead and add that and commit it. We'll say boilerplate for HTTP server complete. For this project, we're going to use Postgres as our SQL database. It's a production-ready database. In fact, it's the one I used to build boot.dev. You're going to need to install Postgres on your local machine, make sure that the Postgres server is up and running, and that you have a client installed that you can use to make kind of one-off SQL queries against it. I have detailed instructions on how to do all of that in the text instructions for this project over on boot.dev. So again, go check those out if you need to figure out how to install Postgres locally and get a Postgres client up and running on your machine. I use pgadmin, so that's what you'll see me using in this tutorial. So if you followed those instructions, then you should have a Postgres server running on your local machine and a Postgres client installed. Again, I use pgadmin. That's what you're seeing here on the screen. Okay, so because Postgres is running locally, I have this localhost server here in pgadmin that I've connected to. Again, that's the Postgres server running on my own machine. And under databases, I have kind of the built-in Postgres database, but I want to create a new database that we're going to use for this project. So in this case, I'm just going to name it RSS-ag, and we'll create that database. And then here within the RSS-ag database, as long as the kind of icons are gold, then you're connected and everything is working, at least up to this point. Let's run a quick query against the database just to really make sure everything's working. So I'm right clicking here on the RSS-ag database, and I'm going to click Query Tool. And from this tool, I should be able to just write some raw SQL. So I'm going to go ahead and do a select version. This should just return the current version of Postgres that I'm using. I'm on version 14.7, and as long as you're on something 14.7 or newer, you should be good to go. Now, it's important to keep in mind here that pgadmin is just a client for interacting with an SQL database, right? We're able to write raw SQL code here and run it against our database server. If you think about it kind of in an analogous sense, pgadmin is basically just the same thing as the Thunder client, where the Thunder client is a client for running one-off HTTP requests against our server. pgadmin is a client for running one-off SQL requests or SQL queries against our database directly. Next, we're going to install two command line tools that will allow us to work with SQL databases from our Go code much easier. Now, these aren't fully fledged ORMs, if you're familiar with that term. These are kind of lightweight libraries that allow us to work with SQL databases using the standard library and just sort of streamline the process for us. The first one is called SQLC. And again, you can find all of these commands in the text instructions over on boot.dev, so be sure to be following along over there. But we're going to use the go install command to go grab SQLC and install it into our command line. Once that's done, you should be able to just run SQLC version to make sure it's working. Next, we'll install Goose the same way. So go install, and then the installation path for Goose, again, that link is over in the text instructions. And then you can make sure that Goose is installed and working correctly by typing goose-version. The great thing about SQLC and Goose is that they work based on raw SQL. There's no kind of fancy query language that's unique to those tools. We can just write SQL queries. And we're going to store all of that in our repository. So I'm going to create a new folder, just called SQL. And in there, I'll create a new directory called schema. And this is where we'll store all of our table definitions, or more specifically, our migrations. So we'll start with a users table. And the way Goose works is it runs the migrations in order. So we're going to start with a 001 migration, and we'll call it users.sql. From a very high level, the way that database migrations work is they have an up and a down statement. So for example, here we're creating a users table. The up statement will just create a new users table, and the down statement will delete that same table. So any down statement should just undo the operation of the up statement. And that just makes it easy to roll back changes to our database schema if we ever need to. The Goose command line tool works based off of SQL comments. So we'll start with a comment -- plus Goose up, and -- plus Goose down. And then anything we type here will be considered an up migration, and anything here will be a down migration. So let's start with the up migration. It's going to be create table users. And the first field will just be called ID. It'll be a UUID, a universally unique identifier. I prefer UUIDs to integer primary keys for a number of reasons. I'll link a blog post down in the description below. And that's just going to be a primary key. Next, we're going to need a created at, which is a timestamp, not null. So we must have a created at, must have an updated at, same thing. And then a user will also have a name, and we'll just make that a text field. Again, let's say that's not null. I need to remember to terminate my SQL statements with a semicolon. And for the down migration, it's pretty simple. We'll just drop the table. So drop table users. All right, let's run our migration. But first, we're going to need to be able to connect to our local database from our program and from our command line. So very first thing is we'll need a DB URL, and we'll set it equal to the URL that we use to connect to our local Postgres server. So this isn't to connect to pgadmin. This is the same connection string that pgadmin uses to connect to the database server. We want to go directly to the database. So it's going to look something like this. Postgres is the protocol, so ://. Again, this is just a URL. And then we have the authentication part, which in my case is wagslane, because that's the user on my machine. And then : and then password. If you have a password for your local database, this is where it goes. I actually did not set one up because it's just my local database. And it's going to be at localhost :5432, which is the standard port for Postgres. And the last part of the URL is just going to be the database name that you created. So in my case, I believe it was RSS ag. Okay, so your URL should look very similar to this, with maybe, the username, the database name, something like that could potentially be swapped out on your machine. Okay, to run our migration here, I'm going to copy this database URL, and then I'm going to cd into this directory. So cd SQL schema, and then from here I can run goose Postgres. So I'm telling Goose that, hey, I'm using a Postgres database, and then I'll paste in my connection string and type up. So this will run the up migration. A nasty error here. Turns out I forgot some commas. We need to separate all of these field names with commas. Cool. Save that file. Let's try again. So we got OK. 001 users.sql, no more migrations. So that should have run. Let's check pgadmin to make sure that it works. So now over in pgadmin, under my RSS ag database, I should be able to come into the schemas tab, the tables tag, and I can see here that I now have two tables, Goose DB version. So this is an automatic table created and managed by Goose. And then I've got the users table that I just created. Let's go ahead and do a select star from users, and we should just be able to see those column names come back. Now let's make sure that the down migration works as well. Go ahead and run the exact same thing, but this time down instead. And you can see that it down migrated the same file. Now over in pgadmin, if I right click on tables and click refresh, you'll see the users table's gone, and this query should fail now. Okay, so let's re-up migrate to get that database table created again. And then the interesting thing about migrations is you can rerun the same up migration and you won't get any errors because Goose knows that you're already migrated up to the most recent version of your migrations. Now it's time to write a query. So we're using SQLC to handle our queries and Goose to handle our migrations. So to get SQLC set up, we need to create a new file in the root of our project called sqlc.yaml. I'm going to paste in this configuration here. Basically, it's just telling SQLC what version we're using, what database engine we're using, and where we're going to store our queries. The raw SQL for our queries are going to live in the SQL directory under a new subdirectory called queries. We've specified that here, right? And here I'm going to create a new file. I'm just going to call it users.sql. And again, this is where the SQL will live. And the way SQLC works is that it takes the SQL statements and it generates Go code, type-safe Go code that matches the SQL. Every SQLC query starts off with a comment that starts with its name. So name, we'll do a create user statement, and it returns one record. So we're saying, I want a new function called create user. Oops. And it's going to return one user. That statement will be insert into users, ID created at, updated at, and name. Values, $1, $2, $3, $4. Okay, so what's this nonsense, right? In SQLC, each $number is interpolated with the parameters for the function. So this statement will create a new function called create user with 4 parameters. And the first parameter will go in right here, the second one, the third one, the fourth one, etc. So it allows us to create queries that take arguments as input. And then we'll end the query with just returning star. Okay? We want to create a new user and return that record, right? We expect one record back. Now let's use SQLC to actually generate the Go code for this query. We always run SQLC from the root of our package rather than within the query's directory itself. And the reason that works is because we have this sqlc.yaml file at the top level. Okay, so if everything was written correctly, we should be able to do SQLC generate. And what happens is it goes and reads that query, and it also reads our table definitions, which we've specified here, right? SQL/schema. So it knows the shape of our tables, and it knows the query we want to create, and it can go automatically generate all of this Go code in the internal/database package. Now we need to actually use the database in our Go code. So here in main.go, I'm going to create a new struct called API config, and it's going to hold a connection to a database. Now, this database.queries type is actually exposed by that code that we generated using SQLC. So you can poke around through this package and kind of get familiar with the generated code. We never manually update this code that's generated by SQLC. It's completely managed by SQLC. We're just going to write raw SQL to generate this code. Okay, next thing we need to do is import our database connection. So here in .env, we have our DB URL, and we need to grab that and pull it into our application. We're also going to need to disable SSL mode. So SSL mode equals disable. And this just tells our code, hey, we don't need to be connecting to our local database using encryption. We kind of trust our local database. So we'll parse that as a string. So I'll do DB URL. And if the database URL is not found, then we'll report a message. or we'll log an error message and exit. After that, we need to actually connect to the database. So the Go standard library has a built-in SQL package. We can do sql.open. The driver name that we'll be using is just Postgres. And then we can pass in the connection string. And this will return a new connection and an error. And again, if there's an error, we'll just go ahead and log a message and exit. Can't connect to database. Now, this is kind of a weird, quirky thing about how Go handles databases, but we actually need to import a database driver into our program, but we don't actually need to call anything from it. So the SQLC docs mention this, but basically we just need to include this line at the top of our program, and we do need to import it. So I'll do a go get on that lib/pq. And we'll import it using that underscore just to say, include this code in my program, even though I'm not calling it directly. Okay, with that there, now we should be able to create a new API config. And let's just call it API CFG. And it takes as one of its fields a DB. Where am I at? I think I scrolled too far. DB, oh, and I should probably go mod tidy and go mod vendor so that I stop getting weird errors in my VS Code. Okay, this API CFG takes a database.queries, but if you look here, we don't have a database.queries, we have an SQL.db. So we actually need to convert it into a connection to our package. And we can do that with database.new, and we pass it as input the connection, and we'll get back queries error. Here we can say if error does not equal nil, and pass in the queries to the struct. Nope, did I do that wrong? Maybe this doesn't return an error. Mismatch, two variables, but database.new returns one. Okay, cool. So this actually can't fail. It's just a simple conversion. We could actually even just do this. It's probably easier. Great. Now we have an API config that we can pass into our handlers so that they have access to our database. Let's write that create user handler. Okay, so I'm just going to copy paste this handler readiness and change it to handler user. And we'll update this to say handler. This will be the create user handler. Now, here's the interesting thing about HTTP handlers in Go. The function signature can't change, but we do want to pass into this function an additional piece of data. We want to add this API config. So the way we do it is by making this function a method. So we do API CFG is a pointer to an API config. So our function signature remains the same, right? It still just accepts these two parameters, but now we have some additional data stored on the struct itself that we can gain access to. And let's hook up this create user handler in main. So we'll add it to the v1 handler. We'll do v1 router dot post. We want this to be a post request to /users. And we want to use the handler create user method, which we defined on this struct. So we can pass in API CFG.handler create user. And now our handler will have access to the database. Okay, cool. This handler needs to take as input a JSON body. It should expect some parameters. So we'll do type parameters is a struct. And I think for now we just need a name. And we need to parse the request body into this struct. So we'll do json.new decoder and r.body. Okay, and this returns a decoder. And we can do decoder.decode and we want to decode into an instance of the parameters struct. So we'll do params is an empty parameters struct, and we'll decode into a pointer to parameters. And this returns an error if anything goes wrong. If there is an error, then we should use that handler function that we made earlier, respond with error, and say something like, well, we need to pass in W. If something goes wrong here, it's probably a client-side error, right? So I'm just going to pass in a 400. And we'll say, let's see, error parsing JSON. Cool. And then we'll return because we're done at that point if there is an issue. Okay, otherwise, we have access to a name. So we can use our database to create a user. So we do API cfg.db.createUser. Now, this is the method that SQL generated for us, right? Because it read our createUser SQL and it created a createUser function for us, right? And it created the parameters as a struct. So that's pretty convenient. Let's see how this works. So createUser accepts a context and some createUser params. So I'm going to use, I think it's r.context. There we go. So that's the context for this request. And then we pass in database.createUser params. This is a struct, and it should have, all of our types that we need to pass into the createUser function. Okay, so first things first, an ID. The ID is a UUID. And this is the first point at which I think we've needed to use them. So we're going to have to import this package. So github.com/google/UUID. This is a very well-known UUID package in Go. We will go get it. With that installed, we should be able to do UUID.new. And that will just create a new random UUID. And if you weren't familiar, this is what a UUID looks like in string form. It's basically just this really long random bit of, in this case, represented as text that we can use as a primary identifier for every user. So every user will get their own random ID. Cool. I should probably go mod tidy, go mod vendor. It's just good practice every time you install a new package to make sure you vendor it, and go mod tidy kind of cleans up any unused imports and resolves some issues there. Okay, created at, I'm going to set to just time.now.utc. It's created now. And then updated at should represent the last time it was updated, which would also be now, right? Because we're creating something new. And the user's name will just be params.name, right? It's whatever was passed in to this HTTP request in the body. Oh, and I just am now realizing that I messed up this JSON tag. Should look like this. Okay, cool. So create user should probably return an error. Yep, returns a new user and an error. Again, if there was an error creating the user, we'll want to respond with an error. And we'll say, couldn't create user. 400 seems fine. And then we'll actually respond with the user object itself. Okay, database.user, and see how that goes. Well, let's actually take a look and see, what does a database.user even look like? I'm curious. Yeah, so all these fields are exported, so they should marshal to JSON just fine. Let's go ahead and run this and see what we get. Before we run the code, though, it looks like I've got a couple little things to resolve here. So error is already defined there, and then here, oh, I'm messing something up. We need to pass that in. We need to interpolate that. Cool. Oh, and here as well. %v, because those are errors. Okay, cool. Now let's go ahead and build and run the code. So go build and run RSS ag. Okay, server has started. So let's go ahead and open up the Thunder client. And now we'll be sending a post request to the user's endpoint. And we'll be sending in a JSON body. Oh, let me grow this just a little bit. And we need to specify a name. I'm going to create a new user called Lane. And let's see what happens. Couldn't create user. Database wags lane does not exist. It looks to me like I probably messed up my connection string. Let's go take a look at that. So here in .env, yeah, okay, I forgot to add the name of the database here at the end. So we need to do / name of database. All right, let's try that again. Let's rebuild the server and resend that request. Cool, we got a 200 response. It looks like that is a new random ID. Great. Created at, updated at, and the name. Next, just to make sure that the record actually was created in the database server itself, I'm going to pop back over here to pgadmin, refresh my tables. There's our users table, and rerun this select star from users. Perfect. Looks like we've got one record in here with all of the data that I would expect. Now, I want to make one more optimization to our code here. You can see in this JSON response that the key names in the JSON object are the same as the exported key names here in the user struct in the database package. Now, we can't change this struct manually. Again, this is generated by SQLC. So what I think we should do is instead create a new models folder, models.go, in the main package. And here we'll create our own user type. So type user struct, and it will be nearly identical. So let me go grab this one. Be nearly identical. The only difference at this point is that I'm going to add JSON tags so that I can specify, what these names should be. And we've been using kind of this snake case convention, so I'm just going to stick with that. So updated at and name. And I'm going to create a function. We'll say database user to user. And it will take a DB user and return a user. And all this does is return a new user struct where we've kind of populated it with all of the stuff from the database user. So again, the purpose of this is really just I want to own the shape that's being returned over the wire, right, on our HTTP responses. And now I have the power to configure that easily within my application. So we'll go ahead and just paste these in here. Okay, and then in my user handler, rather than responding with the database user, I'm going to respond with our user. Cool. Let's rerun and build that. And let's run our query again. Now remember, we already have a user in our database, so I'm going to create a second one. Let's call this one Rob. And this time you can see we have those snake case keys. And again, I'm going to go check in pgadmin to make sure that Rob is there. Perfect. Now we've got Lane and Rob. And you can see they have different randomly generated IDs and their timestamps are slightly different. We're going to be using API keys to authenticate our users on this server. The nice thing about an API key is not only is it a little more secure than a username and a password, but because it's so long, it also serves as a unique ID for that user. So we don't even need a combo of username password. We can just use the API key in order to kind of uniquely identify people. So we need to run a migration that adds a new field to the users table so that we can store their API keys. Now, we've already created this migration that creates the users table, and we don't want to modify this because it's generally a really bad idea to go modifying your existing migrations. Instead, we create a new one. So I'm going to create a new one, and we'll call it 002 because we want it to run after the first migration. And again, Goose uses these numbers to know in which order it should run the migrations. And we'll call it users API key. And the migration statements are going to look a little bit different. Okay, so the up statement is going to be an alter table. So alter table users. We'll add a column, and we'll call the column just API underscore key. It's going to be a varchar, so varchar 64. Now, the difference between varchar and text, at least for our purposes here, is that the varchar is exactly 64 characters long. So we're saying we want our API keys to be 64 characters long. And we want those API keys to be unique. No two users should have the same API key. We also don't want them to be null. And we're going to set a default API key. And this is important because if we didn't set a default, we'd run into an issue when we run this migration. Remember, we already have 2 users in our database currently. So if we just try to add a column that has these unique not null constraints on it, then what's the SQL database going to do? How is it going to generate new API keys that are unique and not null? Typically, it would just default the new the field in the existing records to null, but because we've said they can't be null and they must be unique, we need to provide a unique default for every new record, or for every existing record in the database. So the default value that we need to add, again, needs to be unique for every person. So we're actually going to have to use some random number generation so that we can generate a unique API key for every user. And this is the snippet of code that does that. Again, you can go grab this in the text instructions for this project over on boot dev. But let me explain basically what it's doing. We're generating some random bytes, and then we're casting it into a byte array. And we're using the SHA-256 hash function to get kind of a fixed size output. So we're saying, take a big random slice of bytes, hash them with SHA-256 so that we get a fixed size output, and then encode it in hexadecimal. And that's so that we get 64 unique hexadecimal characters. This will make more sense when we actually run the query and you see what the output looks like. And then as far as the down migration goes, we just need to alter table users and drop column API key. Again, down migrations should just undo whatever was done in the up migration. Let's go ahead and run this migration. So I'm going to need to change directory into SQL schema. And then we'll run goose postgres. And then let me go grab the connection string. Now we do need to peel off this SSL mode disable. Goose doesn't need that, just our code needs that. So I'm going to grab the rest of the string and we'll run an up migration. Cool, so it looks like it ran successfully. Let's go see if those default values look good. Run the select star statement, and there you can see the new API keys. So big ol' hexadecimal strings that uniquely identify every user and should be kept secret by the user because just the API key is enough to authenticate the user. Now that we've got our migration and we've updated our schema, we actually need to go update our query, right? We need to be creating new API keys for new users. So let's go update our create user function. It should now accept an API key as the last parameter and pass it in here. Actually, you know what? If we do it this way, we're basically telling our application code, hey, you need to go generate an API key in the same way that we generated it here in our SQL. I think it would actually be easier. What if we just take this and plop that in here? Right? So now we'll use SQL to generate the new API keys. We don't even need to update the function signature of our create user function. Cool. So the SQL will just handle the creation of new API keys every time a new user is created. All right. Now we should be able to run sqlc generate. Insert has more expressions than target columns. Let's see. Oh, right. Sorry. We do still need to pass in the API key as the column name. The difference is because we are not using $5, our function signature won't change. This got a little confusing. I was reading it like a function signature, even though it is SQL. Okay, run that again. It went off without a hitch. You can see it updated a few files in our database package. Now we should be able to go use that in our code. But before we test our server, let's add one more thing. Let's give us a way to get a user. So we'll create a new function, and this one we'll call get user by API key. And it should return a single row. And it's going to be a select statement. So select star from users where API key equals $1. And we'll run SQLC generate again to generate the code for that query. You can see it created it here. So in our handler user function, we actually don't need to make any changes to our create user handler, right? We didn't change the number of parameters that we need to pass in for the API key. It's handled kind of under the hood by the SQL query. But we do need a new handler for getting users. So let's go ahead and add that. So I'm going to copy paste that, do handler get user by API key. Maybe we can let's just simplify this. Let's just call it handler get user. Now this handler is going to look very different. This is an authenticated endpoint. So in order to create a user on our API, basically to register a new account, you don't need to have an API key. But if you want to get your own user information, you have to give us an API key first. This isn't going to be the only authenticated endpoint, or the endpoint that you can only do if you're logged in. So I think it makes sense to kind of abstract the logic for getting a user by their API key into a package. So under the internal package here, where we have our database code, I'm going to create a new package and we'll just call it auth. And in there, I'll create a new file. We'll call it auth.go. And this whole package will just be called auth. Now, the only function that we care to export in this auth package is going to be this one called getAPIKey. And its purpose, getAPIKey, will say it extracts an API key from the headers of an HTTP request. So it's going to go into the headers, look for a specific header, and see if it can find the API key. If it can, it'll return it. Otherwise, it will return an error. Now, as the authors of this server, we get to decide what we want the authentication header to look like. So I'm just going to say, example, let's expect an authorization header. So the key of the header will be authorization. And the value will be API key, and then some, like insert API key here. Okay, so we're looking for a header of this format. So first, let's look and see if we can find a value associated with the authorization key. We're just using the HTTP standard library here, so we can do headers.get authorization. And this should return, let's see, a string. Okay, so the value associated with this header key. Now, if value is the empty string, then we can just say return empty string and an error, say errors.new, no authentication info